Howdy y'all. Today we're going to cover installing Thaddeus Picchio's build of NPM2 on small computer central systems. We're going to start with Z180 on the SC126, which is a very easy system to run NPM2 on. For Z180, you want the DREQ line pulled high. It's DREQ. That line needs to be pulled high for this particular build to function. And it's between the CF card and the rest of the system, really, where it matters. On the SC126, there is a jumper for that, so you just set a jumper. So you'll see that I don't do any special hardware preparation. I've already got all my jumpers set the way I need to. This will build on other SCC Z180 computers, but you will need to install a semi-permanent pull-up resistor somewhere on your bus in order to actually use the system. And that's what I've done. I may show you that on another video, how I've done it on another system, but for now we're just working with the SC126. If you have a different Z180 build from Small Computer Central, again, it will work. As long as you pull that line high, the DREQ line, it will function just like this. So you can follow along, just make sure that you have that DREQ line pulled high somehow. This build also supposedly works for Z80, although the clock speed on that is much slower and it may not be very useful. Even the author themselves say, you know, you need at least an 8 megahertz clock for this to be useful. And even then, 8 megahertz is a little slow. This is a 18 point something megahertz clock. And even then it's a little slow, but especially with two users doing resource intensive tasks, it can hang for both users for a little while. But it is the first multi-user operating system for home computers, and it's very cool to tinker with. You will see at the end when I demonstrate things that your system may not come out looking like my system if you follow along here. And that's because I have skipped a step in this video where we set up user number one, the second user on the system, and give them all the tools we need. Now, that's something that I will cover in the next video when I teach how to use NPM2 effectively. But for now, just know that if you follow along with this and your system looks a little different than mine at the end, especially for user one, because it will look different, don't worry about it. We will cover it soon, very soon in the next video. I'll try to have that out shortly. So yeah, until then, enjoy. I hope you can get NPM2 up and running, and I hope you have fun. Now, I do hope that you may visit my Patreon. I really could use some help. You may notice that this is a little lower quality than what I usually film. I recorded the audio later, and it's kind of not the best audio. I just don't have all my equipment here with me in Uruguay, where I'm living now. I'm living in hostels, and so, you know, it would really help if I could get some patrons to kick some funds my way so I can get the rest of my equipment shipped to me and hopefully a place to live where I can actually set that equipment up, because right now I'm bouncing around from place to place for as cheaply as possible. All right, well, y'all enjoy and let me know what you think. Howdy y'all, welcome back to Little Bits. Today we're going to talk a little bit about running NPM2 on the Zilog 180 CPU. We have a project, fairly new project, that I've written about before on my blog, and it brings NPM2 to the RC 2014 bus, which happens to be compatible with this build. We're gonna work on the Z180 first, and then we're gonna try and do the same thing on the Z80. I'm gonna introduce everybody to NPM2, the very first multi-user operating system on Zilog hardware. Yeah, this video, we're just gonna learn how to set up this system for it and get it up and running, and then I'll produce some more videos about how to actually use NPM2 in a productive and effective way. There will be a little bit of sidetracking. One thing to note is this build of NPM2, though it does have a program in it for setting and reading the time, it does not support the real-time clock. It also does not support the micro SD card. So we're going to be using the CF compact flash card over here. We're also going to be using this terminal to demonstrate the multi-user system on two different computers. Mostly we're going to be using an FTDI to serial connection on a simple laptop, but when we are using two different users, we will also set up the second user on a monitor with their own keyboard so we can demonstrate the multi-user aspects of NPM2. And we're starting with the Z80 because it does have a faster clock, and the faster clock does allow for a little bit more capable of a multi-user system. But we will also be using a close to 8 megahertz module if we can get it up and running on a regular Z80. There is a port available. It uses a different type of memory system, and we will try to get it up and running. And if you don't see videos about it, it's because I didn't get it working. So we'll get started. We're mostly going to be working on the command line today, so we're going to switch over to the screen. Okay, so I've covered this in previous videos, but we are going to spend the first portion of this video getting this system set up essentially from scratch. Now, we aren't going to flash the ROM drive, but we do need to grab this CPM-D for the machine we're going to be working with. We're working with, as I said, the SC127, which is a Z180. I said Z80 earlier when I was referring to it. It's a Z180. And this particular build of CPM from Small Computer Central is what we need. So we're downloading it now. It's pretty small, so it's already downloaded. You can see we're logged into the system. We'll switch to a terminal here on the computer itself. Ignore my completely legally obtained games here like Pokemon. Shh, no Pokemon. No such thing. There's no such thing as Pokemon. Not in this world. So ignore that. We're going to unzip the file we just downloaded. And that gives us a number of packages. These package.txt files are identical between all the packages, so you don't really need to worry about those very much, although we are going to install them on the system. Well, we're going to install one of them on the system. This is how we get connected to the terminal for the 8-bit computer from Linux. I use Minicom, you can use Picocom, you can even use Screen, but Screen is a little more bare bones without some additional options set. We can boot into any of these from the ROM we have already installed on the system. But in order to get into CPM, we need to have CPM installed on a compact flash drive. This compact flash format file is going to format a fresh 128 megabyte drive for us, which is what this build expects. You can use larger, but I've had some problems with larger file systems when doing multi-boot things. It's not usually an issue with CPM, but if you're booting into Collapse OS as well, which we cannot yet do on a Z180, we need to port it to Z180. The original author has only built out for Z80. So here we go. We also installed the system itself. So now we can get into CPM at this point. And I've covered why this works on previous videos, but SCM, the small computer monitor, just knows how to accept these files. So we booted into CPM, we're saving the download.com file. This will allow us to install those package.txt files, which contain more software. So we reboot back into small computer monitor, and we're actually going to send a copy of the X modem tool from the NPM project itself. Now, the NPM2 project we're using contains a build of X modem that works well on every version of CPM I've installed it on. So far, in a lot of my videos, the only system we have X modem for are the ROM WBW builds, but this particular build of X modem is made in order to allow us to get the NPM2 files onto our system. But it works for anything. We could call it X modem if we want, but most of the time we just call it XM. download.com. And now we have both tools that we're going to use to actually install software onto the system. Since we're running CPM2 as a base, we do want our CPM2 administrative tools, which come from this package down here. Not the Pokemons, ignore those. You don't see any of this. There's no such thing as Fallout. Okay, we have an error here, and this error is happening because we need to change a setting in the Minicom terminal itself. Now, you'll see me flipping this setting on and off, this hardware flow control. For download.com to work, we do need hardware flow control turned on. I don't know why, it just seems to fix things. And for the X modem program, we actually need to turn it back off because, again, I don't know why. It just seems to fix things. So one expects hardware flow control to be on and the other doesn't. It used to be that Minicom had it on by default and I would just turn it off when I needed to, but now it's off by default and I'm not sure why. But we've got all our stuff now. And I'm going to go ahead and grab a text editor from my own website. I have pre-built this text editor called Vedit. We can use the ed command line, and I do know how to use it, although I often forget because I've mostly been using, I have to relearn the commands because I've mostly been using the Vedit software. You can see we have a number of packages here that I've provided for anybody who wants to kind of get spun up easily. These package files down here use the download.com utility. Some of my newer stuff. Oh, we need Nulu first. So we're going to grab Nulu because Nulu is the archive utility that we use to unpackage archives. And we're going to be archiving up a lot of these files because we don't want to X modem them over one by one. But we're probably also going to grab this vedbin file, which is itself, you can see, an LBR archive. So it contains multiple files because the Vedit tool consists of multiple files even after being built. So now we're going to take a look at the files we grabbed, make sure we got them. I've cleared the screen here just so we have a fresh screen. Here's our XM command and its various options. You can see it shows you uses X modem and the options come last, but we called it XM, so we're just going to say XM, otherwise it won't find the program. We want to give it the file name first and then the option to receive. We don't have, this file name doesn't have to match what it is on the server side, but we are going to name it the same. Note that everything is capitals. Oh, you can see, here we go. We have flow control turned on. So we had a problem with our upload. I forgot to turn hardware flow control off. So I'll change that here in a moment. But first, let's just, well, hardware control flow control is still turned on. We're going to go ahead and upload Nulu because we need that in order to unpack this text editor anyway. There we go. Now we have Nulu.com. You see I tried X modem again. I edited that out. I realized here that flow control is still turned on. And this is just me typing some junk on accident. There we go. Now this copy of Xmodem doesn't work once we're actually booted into npm2. That is a problem that the original author has said he's working on, but it's very difficult because of the design of how npm2 handles its queued serial consoles, which kind of interfere with Xmodem. So there's some work to do on that front, and maybe I or my audience can help progress that a little bit. But you see here we've extracted all these files from the archive, and actually this this command line doesn't work quite the way that I expected it to. You'll see a little later that when I'm extracting things, it kind of behaves differently than I expected to, but we'll talk about that later. I'm uploading some game files because of course I have to have my games in the C directory. And you can see here, even though we have everything set up correctly, this hangs. And that happens sometimes. I don't understand why, but sometimes you just need to cancel out of it and retry. Sometimes you need to reboot the whole 8-bit computer and just retry. And in this case, you can see me just retrying. And I like to liken it to Windows, where sometimes you just got to turn the machine off and back on again. It's not as sophisticated at handling hardware as a modern operating system like Linux might be, or BSD. But we got it working. All we did was retry. Now it's downloading fine. And this particular implementation of XM actually times out pretty quickly. So if you don't get the file upload sent like really quickly after starting the receive command, sometimes it'll just time out. Okay, we've skipped the rest of that download because it's a big file, but you can see I'm going to extract these files now. I forgot to reference Nulu in its correct location in the A drive because I'm working in the C drive. And here we go. We're extracting our games. And you can see Veza.com here is not actually a game. It's the tool that runs the games. And I also distribute that on my site. The Veza is written by a gentleman named Sinstra. npm2 is written by a gentleman named Thaddeus Picchio. I think I'm pronouncing that right. I might not be. I think it's a Polish name or a Ukrainian name or yeah, I want to say Polish, honestly. But I could easily be wrong. Forgive me if I'm way off base there, Thaddeus. All right, so we've got all our games, and here's an example of me starting one up. I know that this is a big, important piece for a lot of y'all out there running these systems. You're running these systems to run these games, a lot of you. So here's just an example of everything working. And saves work as well. You can save and restore just fine. Here we are in, we're going to set up some tools now. We need some tools to make our LBR packages on our Linux host. This one is weird. It takes a recipe file. So you have to prepare a recipe file, and it has to have certain contents. The very first line is the name of the archive you're going to create, and every line after that is a file to include in it. And so we need to download this tool and build it and install it. Now I've already done it. I have it on my system, but I'm going to show you how easy it is to use this tool. Right, we're looking at the README again that we just saw in the browser, and really what we're looking for is this GCC command. This is what we use to build it. This tool is so simple, there's not even a make file. You just need to build this one file into your command. You can just copy and paste it. And now we have make LBR. Now I installed this in a location on the system that is in my path. You can put it in user bin. I put it in user local bin. That's kind of the more correct way to do it, but it doesn't matter. As long as it's in your path, you can even put it in your home dot local slash bin, and as long as that's in your path, it'll work fine if you don't want other users on your system to have access to it. But it's not exactly a dangerous command, so I just put it in user local bin, and I don't have multiple users on this system, not right now. All right, so now we're looking at the tools. Now, the tools section in this repository is important, especially if you're going to use the build.cmd files, which we are going to do here. But what I found is that this thing is missing a bios.bin file that is usually included with the ZXCC command line tool chain, which is a tool chain designed to let us build Z80 software on our x86 machine. You can see we're calling ZXCC here in this script, which is included. But a lot of times when you first pull this repository down, which we'll talk a little bit about later, you may try to run these commands and get an error that bios.bin is missing. So here I've placed it manually into these locations, and I only need it in one of these locations. I think I just need it in that top one. But I tried one of them, it didn't work. I tried another one and it worked. And so I just didn't remove the extraneous bios.bin file. And I'm about to add another extraneous bios.bin file, probably in the wrong place. But I just want to show you where you can get this file from. So if you get an error about missing bios.bin, you can easily get it. So first you want to pull down the ZXCC code base itself from GitHub. And I already have it here, so I'm in the directory. And you can see it includes the bios.bin file. I'm not sure why it wasn't included in the npm2, because it's not exactly a closed source tool. It's not a proprietary file. It's just, and you can install ZXCC Linux native and use it as your build toolchain instead, but you will want to rewrite those build.cmd commands into something like a make file instead and kind of replicate its functionality, which we haven't done here. Now I have 3 and I only need one of these. So I'll figure out which one I need exactly and remove them. But if you wanted to move the bios.bin file from the old or from the ZXCC repository into the npm2 repository, that's how you do it. Now, this ROM SCM is where we got our Xmodem implementation. So that's the file we unzipped. I've done that in a previous step, but that's where if you download this repository for npm2 and you want to get that XM file directly from it, that's how you do it. You get it from that zip file we just showed. Here we're looking at the Zios.z80 for the Z180, and you can see by default this does not use the 115/200 baud rate that we are accustomed to. So we want to change these lines before we build and install the kernel. You can see here I've already changed one, but we want it for both users. We want both users to be running at 115/200. This comment is not important, really. It's just, and we change it from 20 hex to 10 hex, which is not the correct way to talk about hex, but I'm not going to change how I talk about hex because we want to divide by less. If we divide by more, it will go slower. So we just divide by half, and half of what we're dividing by, and we get the correct clock speed for our serial lines. Now, you can see I run wine and I call the build command. And as long as everything's in the right place, that build command will run correctly using wine. These files we want because they're system files. We want the kernel files. You'll actually see I'm forgetting to add a necessary file set here, which we will go grab later and correct, but I don't notice that until after I have npm up and running and realize I can't build C code because I'm missing certain libraries. But here what we're doing is we're looking for the files we need. We're replacing bank xios.spr with the one we just built because we changed something in it. This bank xios.spr in the kernel directory is pre-built, and it's pre-built with the settings that we didn't make. So now we're going to make just a directory to consolidate stuff into so that we can make our LBR archives and transfer them to the system without having to do it one file at a time. Because as you can see, there are a lot of files here. So we grab all the loader files. Here I'm trying to figure out how to keep the README file from going over, but instead I just do it and then remove the README file. Well, the source file, we don't need that source file unless we plan to build loader BIOS on the system itself, which we don't plan to do. And here's the README file I was talking about. We're going to remove that. We need all the stuff from kernel. Since we don't really have nested directories, I'm not going to copy using recursion because I don't want a nested directory, but I do want the stuff from in there. We're probably not going to use all of that, but to have it on the system is a good option so we can tinker. Now I've skipped a very important step here, and I did not realize it at first, but you're going to see that I will go back and correct it and show you how to correctly build the kernel. Because once we've made changes to the XIOS, we need to rebuild the kernel using the new XIOS before it will understand those changes, before those changes will be incorporated. You can see the file I'm going to forget here is include 80. I am about to move bin 80 and lib 80 from the tools/cpm directory, which these are CPM tools that will run on CPM2 before we boot up npm. They'll also run on npm. I accidentally called the wrong command. That was a typo. Or actually, I forgot. I didn't forget the include. I forgot. I think the lib 80. One of these directories I forgot. And anything with the .lib files in them, which we need for building code, for building C code specifically. The Y2K stuff, I'm pretty sure all of these are fixes that are pre-built into the provided commands. I just wanted to take a look at them real quick and make sure there's nothing in there that we need to grab. It doesn't seem that way. Here we're creating our recipe file. And I almost name it wrong here, you can see. The .REQ is not necessary, it's just an extension that I added so that I know it's a recipe file. And we're going to name this a capital just to distinguish it. We don't want to include the recipe file itself. And you can see I left a README file in there. I still ended up with that readme.md. We removed that later. You don't need to worry about that. It's not going to take up a lot of space. It can be removed later. You can rebuild this later without it. I managed to end up with that README file still in the collection of files. All right, now we're going to move the whole. Oops. You can see I I'm still in the C drive and I'm sitting here acting like the command just started, but you see that error XM question mark. It's telling me it can't find the command I just tried to find. I just tried to run. So I'm sitting here trying to upload this thing. And I show you some of these mistakes so that you can get a sense of how to troubleshoot them, because you're going to do some of these things. I can almost guarantee you're going to make some mistakes along the way. You're going to forget. You see how I'm trying to send this thing. It tells me give your local X modem the receive command, but I didn't. You can see, and I'm trying again here, and I realize, oh, I'm in the wrong drive. So, if you mess up and things aren't working right, just take a step back, look at your command line history if you can, and you'll get a sense of what you need to add or change. Okay, so we're trying it again. We've actually got it running. It's receiving, and we do want this file in the A drive. It has to be in the A drive. To be more clear, we want the files within it to be extracted into the A drive. In this system, we have A through P. B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. And P is not as big as the rest of the slices here. So most of these drives are a little under 8 megabytes with some, they're 8 megabytes, but with some room for the system's metadata about them. So they're a little under 8 megabytes that we can use. And the last drive P is a little bit smaller than that. It's something like 5 or 6 megabytes. And I'm not sure the reason for that exactly. I think it's because it expects a 128 megabyte drive, and it wants to leave a little room on the end, or there's not exactly enough room on the end if you do the math straight binary. But potentially you could change that and use a slightly bigger compact flash card and have the full size. But it can only do 16 slices or drives. Here we go. We've got the files. We're going to extract them. And then we're going to watch the mistake occur. Oh, see that build.cmd? We don't need that either. That's an accident. We can remove that. That's for Windows. That's what we used to build the kernel, although we haven't done that yet. And because we haven't done that yet, things are going to break. The C compiler included here is the Aztec C compiler. And in another video, we'll talk about using the Aztec C compiler to actually write code for this system. There are a number of third-party tools in here, like the SLR 180, SLR Mac, SLR NK. I have worked with High-Tech C on this system, and it does not work under NPM2. It works fine under CPM2, CPM3. It doesn't work on NPM2. So the Aztec C compiler is where it's at. And we tried to launch NPM here, and we see it's given us an error. And that's because we did not rebuild our kernel. The kernel has no idea what it's doing with this system because we made a change to the bank zios.spr. So we're gonna go ahead and build the kernel And you can see it asks for a bunch of options. For the most part, you can use the defaults. Um, I am told that you want to include I'm going to turn printers off. I'm not going to use printers, but if you want to try and use a printer, leave that number one there. We do want to enable compatibility attributes because that lets us run 8080 code specifically, I think. Everything else, we're pretty much going to go with the defaults, although you'll see here in a moment, I'm going to rebuild this thing again and make a change that I kind of blew through in this first setup. System drive A, temporary file drive A, right? That's the default. I'm going to change that temporary file drive here in a moment to P, just because it's the smallest one. Temp files are temporary, and so we're gonna just use that as the temp file location, just to, I don't know, make me feel like it's a bit of a cleaner install, but we haven't got there yet. So you see I mostly picked the defaults. I changed a couple of things. I'm going to go back and change that. You can see now that I'm rebuilding, it keeps those settings I set. See, number of printers is still 0. Compatibility is still on. Here we're going to change that to P. I don't know why I'm taking so long. And then we're just going to go with the rest of the defaults again. And now we have a kernel configured the way that we want it. Now we need to include those files again, overwrite what we have in our npm binaries directory. We're not worried about the add-on directory. Again, I copied the build.command.cmd file in here, and I didn't really notice, so I haven't removed it. We're going to rebuild our LBR recipe file just because I don't want to end up with, if I ended up with an extra file, a new file, I don't want to accidentally omit it. So I'm just going to rebuild it with everything in here. And again, I still am missing something. I need a file called c.lib, m.lib, t.lib, and I think rom.lib. And those files I have not correctly included in here, but I will notice that a little later and re-add them. That actually might not make it into the video, but in the tools/cpm directory, there is a something 80 that has those libraries. I think it's lib80 that has those files in there, and they are meant to be included with the Aztec C compiler. Okay, we're resending the archive now that we've recreated it. We did have to erase it. Now, some of these implementations of Xmodem will refuse to overwrite an existing file. They'll say file exists. I'm not sure if this one does that, but I have gotten into the habit of erasing files before I try to regenerate them, re-upload them. Now, the reason I've done this twice in a row is because I had an issue with something along the way that I've edited out, and you don't need to do that twice in a row. So we're decompressing it. It's not really compressed. We're unarchiving it, although compression is available. But I think LBR and Nulu are not compressed tools. LBR is not a compressed format, and Nulu won't do compression, I think. But I might be wrong. Now we've booted into npm2. There we go. Here's all the data about how npm2 is loaded into memory. We can do npm2 stat, npm stat. I mean, we can see that data again. And there's a lot we can do with this, but for now, I just wanted to show you all how to get it up and running. And in the next video, we'll cover how to use it effectively, how to write code for it, how to play games on it. I will do a quick demonstration of the 2 terminals. Now, this is the first multi-user operating system for home computers, basically, and it will allow us to have multiple users logged in at the same time doing different things. It's a bit slow, but it is what people used to have. So here we go. We've got NPM up and running. Not yet, actually. We're about to have it up and running, but we're all set up and connected. We've got a couple keyboards. We're about to connect. The machine's not powered on yet, so we're gonna plug it in, which will power it on. We're gonna connect via the terminal. Oops, wrong keyboard. We're gonna do CPM. We see that the terminal came online and it's configured to pick up serial connection 2, whereas this is serial connection 1, which is connected via Minicom on this computer. This is not a separate computer. This is a keyboard and monitor plugged directly into this terminal. And so we're gonna run NPM, hit enter. As we hit enter, we're gonna watch this screen. There we go, we've got a second user. Now, this second user can check their contents, which we set up earlier, while my first user has their own contents. Now, the way we currently have this set up, there are potentially security issues with certain commands, such as user and pip, that if we did not want user 1 to be able to act as an administrator, we would simply not include those commands in our preparation. We would not give user 1 access to these commands, since we're pretty secure that we're not going to give control to anyone but basically myself. I can duplicate some of these more dangerous commands. Now, this is just to get started. There's a lot you can do here, but it's also somewhat limiting because there's very little software support for NPM 2, but we've got it up and running and we can do multi-user stuff. So we'll talk more about how to do that useful stuff in another video. Thanks everybody. Peace.